named the Addington Volcanic Field. If we were to remove the water surface, you would easily see its most striking feature, a massive circular crater in the ground. This crater is known as a maar, a large crater measuring 4,000 feet long, 3,700 feet wide, and an impressive 953 feet deep. However, there are also other vents nearby, including two small volcanic cones and their associated lava flows. While we do not for sure know the age of these two cones, what we do know is the age of its large-scale central maar, which could easily fit an entire American football field inside it. That age comes out to 11,542 BCE. Because this didn't occur after the 9,700 BCE cutoff used to mark the beginning of the Holocene epoch, and the Addington Volcanic Field, to the best of our current knowledge, shows no signs of life at the present, it would be best to classify this volcano as not geologic setting active but instead dormant. Assuming that its two neighboring cones formed in earlier eruptions, I have to assume that the complex is monogenetic, meaning each vent only erupts once. But why did a volcano form here in the panhandle of Alaska of all places? The area does contain other volcanoes, but with the exception of Mount Edgecumbe, none of these have seemingly erupted at anything but a low rate. These regional volcanoes seem to be related to the presence of the tectonic plate boundary marked by the Queen Charlotte Fairweather Fault. This fault seemingly dips to the east, meaning that denser oceanic lithosphere at a certain depth is placed underneath continental lithosphere. Both oceanic and continental lithosphere then experience partial melting, using related fault lines as weak spots to intrude into the crust and sometimes erupt onto the surface. This very region experienced a cluster of eruptions between 15,000 and 12,000 years ago. Decompression melting, which can be directly traced to decompression melting. During the last glacial maximum, this part of Alaska was covered by a kilometer thick of ice, which placed additional strain on underlying rock, making eruptions somewhat less frequent. However, once this ice sheet largely melted, the ancient eruption pressure required for dike propagation to begin at an underlying magma chamber significantly dropped, causing a cluster of eruptions to occur. The eruption in question was likely phreatomagmatic. In Nature and my analysis, although one scientific paper suggests a violent Strombolian eruption, which I consider less likely. Depending on which model was correct, 15,000 to 30,000 foot high eruption plumes that largely distributed trachybasalt to tephrite ash towards the east occurred. At a distance of 25 miles away, this eruption caused a layer of 3.15 inches or 8 centimeters thick of ash to fall. For all intents and purposes, the Addington Volcanic Field is unlikely to erupt again anytime soon, although there is theoretically enough of a possibility that it is worth keeping at least a low level of monitoring on, in my opinion. As a final note, I would like to thank my new patron Justin Cherry for supporting this channel.